Hello and welcome to Go Getter Geeks. In this video, I'm going to demonstrate how we can use JavaPoet to generate the source code based on annotations. For this video, I'm going to expand my previous example of G3 code generator to include a MySQL processor, which will generate DAO layer for SQL database. To begin with, here is the official website of JavaPoet. This is a GitHub repository. Here, if you scroll down to the README section, you will find all the documentation, its usage, and what all features this library provides. So if you want to explore more about JavaPoet, feel free to visit this website. I will also link this in the description box. So here I have checked out the G3 code generator repository. Here I'm going to do a quick setup. I'm going to upgrade this package to use the latest long-term supported version of Java, which is Java 21. Additionally, I'll create the setup on which we can start building our processor. Alright, so I have created the skeleton on which we can start building our processor. Essentially what I have done is I have copy pasted the boiler code from FileDB processor, where I would extract the class which is annotated with FileDB generated and then extract all the fields that are annotated with either unique key or persisted. So in MySQL processor, we are going to look for MySQL generated annotation, and then we're going to extract the unique keys and the fields. So in this example, I'm going to generate two classes. One is the generated DTO, which will be internal representation of the user provided DTO, except it will only include the fields that needs to be persisted in the database. And next we will be generating the DAO class, which will essentially perform four operations, which is create, read, update, and delete, popularly known as CRUD operations. So let's start by creating the generated DTO. Now before we proceed, if you're not familiar with annotation based processing and why this processor needs to be created, I highly recommend the video series that I have created on this G3 code generator. Let's take a quick overview of JavaPoet. Now JavaPoet is essentially a library for generating Java source files. It helps by providing APIs that allows you to create the class structure, the class statements very easily. Now if you're wondering what exactly this library is trying to solve, you can go ahead and refer my FileDB processor example. There I have extensively used Java string concatenation to generate the Java source files. So the most basic example that JavaPoet provides is for generating this simple hello world class, which has a single method main and it just prints out hello JavaPoet. Now how do you do that using JavaPoet? So essentially for generating methods, you create method specs. There you can specify like modifiers, whether it's going to be a public method, whether it will be a static or not. Next, what does that method returns, and what all parameters that method accepts, and at the end the body of the method. Similarly, for creating a class, you will create a type spec, and of course it takes in the class name, the modifiers. In addition, it also takes in the list of methods that you want to add into that class. Now once you have this type spec and method spec, you can go ahead and use Java file class that JavaPoet provides, and essentially all you need to do is provide the package name and the type spec for the class, and what it will do is it will generate this class entirely for you. So in this processor class, we are going to create private method for generating the generated DTO. We will name it as generate DTO. Now this generate DTO method will take in two lists. One is the unique field list and one is the fields list. Essentially our goal with this method is to generate a DTO class which will contain one property for each of these fields, both unique field and the fields, and the setter and getter methods for each of those properties. So we'll start by creating the type spec first, and then we will fill in the placeholders. So here what I have done is created a placeholder type spec. I've used the class name property to extract the name of the DTO that user has given. And then I'm going to append this suffix, which has the value of generated DTO. So for example, if user defined DTO is named students, then this DTO will be named students generated DTO. Next, I have added a modifier as public. I want this class to be public. And then I have put a placeholder for methods. For now, I have put the null, but here essentially we'll be putting our all the setter and getter methods. So let's go ahead and generate the method spec for each of those setter and getter methods. The approach I'm going to adopt is definitely going to create list of method specs for each of the fields. So essentially we'll have one method spec for each of the methods, one setter, one getter. So here what I have done is I've created two lists. One is for method spec, one is for field specs. Then I started iterating through the unique fields first. There I have extracted the name of the field using the getSimple method provided by this variable element class. Next I have created the field spec. This field spec builder takes the type of the field. So to extract the type name, we are going to use the type name class that is provided by JavaPoet, and it contains a get method which takes in the type, and this variable element provides as type method to provide us the type of that field. Next, we have provided the name of the field. Again, this field name we are going to keep exactly the same as what the user has provided. Next, we are going to make this field as private to comply with the encapsulation, and then .build to build this field spec. Let's go ahead and build the method spec for both setter and getter method for each of these fields. Now, while building this method spec, we'll also need to provide the name of the method which follows the camel case in Java. So let's go ahead and create a string util class which will contain a static method which can generate the camel case strings for us. So I've created this capitalized first letter method, and I'm also going to create a method which will convert the camel case to underscores. This we will need when we will convert the field names into the SQL attributes. So the convention I'm going to follow is whatever is the field name provided in the DTO, it should match with the underscore separated version in the MySQL schema. So for example, if user provides a student's DTO having a field named roll number, so user will provide roll number as in camel case like this. And what I expect user to comply with is there should be a corresponding table in the database which has a field separated by underscore. So we need to convert this camel case string into underscore separated string. Now that we have this utility class ready, so we can go back to our generate DTO method. In here, after set, we're just going to capitalize the first letter of the field. So in this setter method spec, what we have done, is we have provided the name of the method first, followed by we have added the public modifier. Since it's a setter method, so it returns void. In terms of parameters, so it accepts the same type of parameter as the field itself is, and we are going to name it the same as the field name. Then inside the body of this method, we're going to add exactly one statement, which is this dot field name equals field name, and then we're going to build the method spec. Similarly, we're going to do method spec for getter method. Now, once we have built our getter method spec, we are going to add both these method specs and the field spec to the corresponding method specs list and field specs list. And we are going to repeat the same process for the normal fields also, which are not unique key. Now, once that is done, we're going to simply add these methods spec and the field spec to this generated DTO type spec. Now, once we have our type spec ready, we can just go ahead and start generating the source file. Now that we have our generated DTO in place, so we can move on to create our DAO class. For that, I'll create a sample DAO class and then we'll go about generalizing that. So there are some errors here which we can ignore for now, but overall this is the template that we are going to follow to create our generalized MySQL processor. So let's create another private method. We'll name it as private generate DAO. Just like our DTO, we'll start by creating the placeholder for generating the class, and then we will fill in the placeholders. So this is our type spec. We've named the class by appending the DAO at the end of the user provided class name. So let's go ahead and define the fields first. So if we look at our template class, so we have three fields here: connection URL, username, password, followed by a constructor. And constructor is also a method. So we'll be using method spec for generating this constructor. So I have created here a connection URL field spec. So essentially this will be a private string connection URL. So we're using field spec, passing the class as a string, name of the variable as connection URL, and then we are adding private and final modifiers. Similarly, we'll be creating username field spec and password field spec. Now this is done, we'll go ahead and create our constructor. For that, we will need parameter spec because this constructor will be taking in three parameters, which is connection URL, username, and password. So we'll be creating parameter spec for each three of them, and then we'll go ahead and create the method spec. So for creating a constructor, the method spec class provides a constructor builder. So here for creating a constructor, we are using a method specs constructor builder, and therein we are providing all three parameters as list, followed by three statements, which is to initialize our final variables. Now, if we look at our template, so far we have done work to create this much code. Now it's time to create our 4 main operations, which is create, read, update, and delete. Additionally, we will also need to create one utility method, which is this convert method, which will essentially be converting user provided DTO into our internally represented generated DTO. So to begin with, we'll start by creating placeholders for each of these methods. Now we have these methods spec. I'm going to generate 4 more private methods representing each of those methods that we want to generate. Now for creating each of these methods, we will need both unique key fields and the rest of the fields. But for delete method, we'll only be needing unique fields. So we will get rid of the fields. Now we'll go back to our method specs here in our generate DAO method. And here we are going to call each of these methods to get these method spec. Once these are done, we are going to add this to our DAO spec as well. At this point in time, we are also going to add our fields. We will also need to add our constructor here. So we are going to add a single method, which will be our constructor spec. So at this point, we have our fields in place, we have our constructor in place, and we have our methods in place. Of course, we need to finish each of these methods as well. But apart from this, we'll also need a private method which will be converting the user provided DTO into our internally represented generated DTO. So let's create a private method for that also. And then we are going to add this method also to our type spec. So at this point, our entire structure for DAO is ready. We just need to fill in these 4 CRUD operations and then we are good to go. So let's start by creating our create method spec first. For that, we'll have a look at our create method here. For this, we are firstly calling our convert method and we are passing this user provided DTO. Once we get our generated DTO, we are defining our insert query. Now if you look at the template for this query, so it starts by insert into, then the name of the table. We are just going to convert the name of the user provided DTO to a all lowercase. So this is another convention that we expect users to follow, which is whatever is the table name, that's the exact name that they should have for their provided DTO. Then we'll have to add parentheses followed by all the field names. And this is where we'll be using our utility method for converting the camel case variable names into underscore separated variable names. And then we'll have the values followed by as many question marks, as many fields are there. This try with resource block, I think this will remain constant for all the methods because we'll be establishing the connection and then we'll be opening the prepared statements. Suppose that for every field that we add in the query, we'll have to call the corresponding setter methods. And for this, we'll just be using the types that user is providing. So for example, if user is using integer, we'll call set int. If the user is providing the type as a string, we'll be calling set string. Of course, prepared statement supports only limited number of data types. So for this also, we'll have to rely on the user to provide the correct data type, which is supported by MySQL. So for example, they'll be able to use timestamp, time, date, array, ASCII string. So all of these is supported by MySQL. So we'll be using this. Since this create method, there will be multiple statements inside the method. We can make use of code block, which JavaPoet provides. So we'll be using a builder. So on this line, we've generated the code to generate this line, which is to create the object of a generated DTO using the convert method. Next, we'll be adding the insert query. So here what we have done is we have written the query up until the point where we can write it. For example, we have written insert into name of the table and then the first opening parentheses. After this, we'll have to append all the field names which are underscore separated. And then we'll have to append as many question marks as many the fields are. So for this, what we are going to do is we are going to create a string builder. We are going to name it as question mark, and we are going to append the question mark as and when we are adding the fields. So I'll just demonstrate that in a minute. And similarly, while we are iterating through the fields, we can also generate these prepared statements, which is to set those fields. So for that also we can take a string builder. Next, we are taking this variable query param index. This will be needed to put this parameter index for the prepared statements. Now that we have these variables ready, we can start iterating through the fields. Now next we need to get the simple type name of the variable so that we can use it in the prepared statement. So for example, if it is primitive, we can do set int and we'll have to do a uppercase of I. If it's a non-primitive, then what happens is this unique field dot as type, this will return the full name, which is java.lang.string. So for that, I think we'll have to create a utility method which can extract just the class name. So in this method, what we are doing is, firstly, we are getting this element as type, which returns a type mirror instance. And then the processing n, which is provided by the abstract processor. So in order to create our MySQL processor, we have extended or inherited the abstract processor class. So this abstract processor class provides a processing env instance, which is an instance of processing environment class. And that class provides a type utils. And then there is a method called asElement to which you can pass your type mirror. Now once you have this element, then you can call get simple name, and what it does is it will only include the name of the class and not the full qualified name of the class. Now we have our variable name in place. We can go ahead and start creating our prepared statements. Now that we have our prepared statement in place, now we need to check how many commas we need to put after each field. For example, if we are at the last field, we don't need to add a comma. So what we need to check is whether we are on the last field or not. But even before that, since we are first doing unique fields, so we also need to consider whether there are non-unique key fields also present or not. So this completes our query and prepared statement generation for unique fields. We can just copy paste this for the non-unique key fields. Of course, we'll have to make certain modifications. So let's go ahead and do that. Now here, since there are no more lists available, so we don't need to make this check. and we can directly make single check, which is whether we are on the last field or not. Once this is done, now it's all about assembling everything. So we'll wrap up our prepared statement. So JavaPoet provides you with the ability to format the code block, and you can use parameterized templates here. So for example, $T stands for the type. There's also, if you want to use string literal so that it surrounds it with double quotes, then you can use $S. And all of these documentation is available on the GitHub link that I have already shown earlier in this video. So the advantage of using this templatized version is if you specify this connection.class, so JavaPoet will identify that it needs to add the import statement. So now here, if you notice, so in our create method, the parameter it has is the user provided DTO. And of course, we just know the name of that DTO. We don't know the exact type of it, which we can use in a way that we are using the other classes like connection and driver manager. So for that, what JavaPoet recommend is that we use a class name class, and this is provided by JavaPoet. And this class name class provides a get method to which you can just pass the name of the package and name of the class, and then this will just return the type of it. So you don't need to worry about user passing the exact class type. And then the name of the parameter, which will all be just the lowercase. So for example, here is students, and then the variable name is lowercase students. Next are all these methods will be throwing SQL exceptions. Of course, you can generate custom exception as well to hide the underlying details, but I'm not opting for it because it's a strictly SQL based DAO, and it is okay to throw SQL exception. And that way user can decide what he needs to do whenever an SQL exception is encountered. So this is how you add the throws statement to a method. And at the end, we've just added our code block. So this wraps up our create method. Next, we are going to generate our read method. For that, let's look at our template first. So here this method is returning a list of students. So this will be a challenging to create because we need to create a parameterized list. So let's check this out, how JavaPoet supports this feature. So here what we have done is JavaPoet provides this class name class, which we've already seen in the previous method also. So what we are doing is we are getting reference of class name for list, array list, by providing the package name and their simple name. And then we are also getting a class name for user provided DTO by providing the package name and the class name. Next, for creating the type, so what we are doing is we are leveraging JavaPoet's parameterized type name, which is a class provided by JavaPoet to represent the parameterized classes. So here what we have provided is firstly the list and then the parameter of this list, which is the user provided DTO. And that we have provided in the returns part. So this way we can generate this parameterized return type. Now why we have created this array list? So if you closely look at this template method, we need to create the object of this list also. So for creating this object, again we'll have to provide the parameterized class. So for that we are using array list. Now let's go ahead and start generating this method body. So here, as you can see, for the first line, we are creating the object of that list. So we have used two types here, and we have provided these two types. So one is the list of user provided DTO, and one is array list of user provided DTO. Now rest of the method should be straightforward, like a create method. Now $L is another literal, so it essentially means a literal other than the string, because if you use $S, it will surround it with double quotes. But if you just use $L, it will not surround it with double quotes. And this finishes up our read method. Now, for the sake of keeping this video short and not being repetitive, I'm not going to cover the update and delete method. I feel these are pretty straightforward. So either feel free to take it as a challenge and finish it yourself, or you can refer the GitHub repository link that I have provided in the description box to see the complete implementation of these methods. For now, let's head to a demo package where I'm depending on this code generator as a dependency. I'm also adding MySQL connector dependency so that we are able to establish connection with the MySQL. Now that the setup is done, all we need to do is create our DTO class. I'm going to name it as students. And now we can start annotating our class. Next, let's build this package. Now, if you look at the target folder, you can check the generated source, and here you will find the generated DTO. So this is our students generated DTO, and this is our DAO class where everything is there. Now let's make sure this generated code works as well. So we're going to create a main class, and we are going to insert the record and get the record from the table. So in this main method, what we've done is we've created two students DTO object, and we have set the roll number as 1, 2, name as John and Tom. Next, we are creating instance of our students DAO. Here I have selected student database, and these are the username and password. Then we are calling create method two times, one for each of these students object, and then we are calling read method to display the student information. Now before I run this, I'll open my MySQL workbench. I'll do select a start from students, and as you can see, there are no records in this table yet. So let's go ahead and run this method. And here it is displaying both the student details. It means the data is added to the database. You can also go to MySQL Workbench and verify that these two records are indeed present in the table. So this wraps up this video. As the next step, you can take it even further with the MySQL processor by adding custom get methods. So for example, you can do get by name method, you can do get by roll number method, and all you need to do is generalize the query, adding the right where statements, adding the right parameters to the method, and adding the right return type. That's it for this video. I'll see you in the next video. Thank you.